This is my worst video. Watch only if you dare, and keep that in mind. I'm only publishing because I promised myself to do daily content, and also there is value in it, so even though my presentation is not up to par what it usually is, you will find some value. So in my last video I talked about when it makes sense to add probabilities, even though it's not mathematically correct, but as an estimation, heuristic, whatever you want to call it. If you have not seen this video, I strongly recommend watching it right now and then coming back to this video, because spoiler alert and all that. Thing is, I learned a lot in this video. The graphs I produced at the end, that was just a last minute thing. I basically saw this also first time, how this actually behaves. I want to make an addition to that video. Let's get a little bit more into that graphs, because there's something I did not say in the first video. First of all, if we look at the graph here, I extended this now to 100,000. So this is the probability of 1 in 100,000. It's kind of the chance that you die every day. If you add those probabilities up, like the chances of you dying within the next few days is roughly the same as the chance of you dying today times 3. But if you keep adding those, eventually the mistake you do by not calculating it correctly gets bigger and bigger. What I noticed with doing this, that all the probabilities look very similar. If you have a 1 in 100,000 chance, I plotted the adding till 100,000. So where you would be actually at 100% if you just added it up. So those look actually the same. The 1 in 100,000 chance looks the same after 100,000 additions. If you add up like 100,000 days, it looks the same as if you add a 1 in 100 chance 100 times. It's very easy to detect the point at which you don't want to do this anymore. The mistake is up to you that you are tolerating, right, for doing it. Let's say your limit is like a 10% mistake by just adding it instead of calculating it correctly. This usually hits something like 20% down the line until you would have the 100% probability if you add all those probabilities up. As you can see in the 1 in 100 chance here, you would need to add this up till 24 something until it crosses the 10% mistake. Same thing for the 1 in 1000 chance. You cross like 230 in this case, like 20% of that. So for the coin flip, the probability is even after 2 tries is already, the mistake is already 25%. I kept doing this a little bit more than just 2 and extended it to like 40 tries. And at this point, the mistake is getting like 95%. So horrible. So you can see the mistake is going a little bit slower up, not linear anymore, but slowing down. At a point where you don't really want to do this anyway. Same for 1 in 100, it actually looks quite similar. So let's say you don't want to have a 10% mistake, but your tolerance is larger, it's 20%. How often do you need to add it up then? Well, it's 47 times. The chance is 1 in 100, that is, so 47% of the full way through. It's almost linear and so on. You can also make that mental guideline that if you need 20%, you need to stop at 40% way down. If you want to have it at 3%, then you need to stop at 3 times 2 is 6 after 6 tries. 6 out of 100, so 6% of the full way to 100. The rise of the mistake you do is always the same. It's very easy to detect the point where you don't want to do this if you know the probability, how small it is, and how often you add it up. If you still haven't watched the video before, I recommend watching it. Or if you have seen it, YouTube probably recommends something else for you.